Welcome to an introduction to vectors. First, some definitions. A vector quantity is a quantity such as a force or displacement that has both magnitude, which you can think of as size, and direction. A directed line segment, when used to represent a vector quantity, is called a vector. A vector has a head, which is at the point of the arrow, and a tail, which is at the other side of the directed line segment. The magnitude, or absolute value of a vector, is written with a V inside absolute value signs and a little arrow above the V, is the length of the vector. So you can see that in the picture on the right. Two vectors are equal if they have the same magnitude and the same direction, but they don't have to be in the same place. The opposite of a vector, V, is written with a negative sign in front of the V, and it's a vector with the same magnitude, but going in the opposite direction. We can do operations with vectors, and one of the things we can do is add them. The sum of two vectors, which I'll call A and B in this example, is formed by placing a vector equal to B with its tail at the head of vector A. The vector A plus B extends from the tail of A to the head of B as shown. In other words, it starts at the very, very first starting place and it ends at the end of the trail that A and B take together. The difference, A minus B, is defined to be vector A plus the opposite of vector B. And in this picture, you can see vector A has the same direction and length in both the sum and the difference diagrams, but vector B, while it has the same magnitude, is going in an opposite direction. And so the vector A minus the vector B is a different vector. It has a different length and a different magnitude than the sum. The product of a scalar, which we'll call x, and a vector, which I'm calling A, is defined to be a vector in the same direction as vector A, but x times as long. So here's a picture of a vector A, and then a vector that's 2 times as long in the same direction, which is the vector 2A. Since vector A plus vector B is equivalent to vector B plus vector A, vector addition is a commutative operation. Vector addition is also associative. And here's some more definitions. So a position vector of a point P that has coordinates x and y on the xy plane is the vector from the origin to point P. And the symbol P with a vector symbol over it is used to represent a position vector of point P. A unit vector is a vector 1 unit long. And the unit vectors in the x and the y directions, which you can see drawn in this diagram along the x-axis and the y-axis, are generally designated with an I and a j. The I is for the vector, the unit vector in the x direction, and the j in the y. And if you extend this to 3 dimensions and have a z-axis, you're going to use k for the unit vector in the direction of the z-axis. We'll see that very shortly. And you can see that if I went x units horizontally, and I multiply x times vector I, and I do the same thing with y, I can get to the point that's got the coordinates x, y. All right, so here's some examples. I'm starting with a vector v that is equivalent to 3i minus 7j. I want to find 5 times that vector. Well, that's pretty basic. You just multiply the vector by 5, and you get 15i minus 35j. If I want the magnitude of that vector, I'm going to have to use the Pythagorean theorem, because think of that point 3, negative 7, drawn, and then I want to find out how long it is. I can use the distance formula, which is basically just the Pythagorean theorem. So 3 squared plus 7 squared is going to be 58. Take the square root of that, and that is the magnitude of vector v. And if I want a unit vector in the direction of v, I'm going to think of a similar triangle that has a side, a hypotenuse, that's 1 unit long. And Ooh, sorry about that. What I'm going to do is take that square root of 58, and I'm going to divide the two components, the 3 and the -7, by the square root of 58. It's going to look like this if you do it in general. A unit vector is a vector divided by the magnitude of that vector. And here you can see I have the vector 3i minus 7j divided by the square root of 58, and I just distributed and separated the parts. More examples. So if I want to add two vectors, just add the components. So 2i plus 3i gives me 5i, and 7j plus 4j gives me 11j. If I want to subtract, just subtract. So I've got 2i minus 3i plus 7j minus 4j, that gives me -i plus 3j. And if you want the angle between the origin and those two vectors, well, first off, just a picture of what it will look like. Those are my two vectors, r and s, and they have an angle between them. And you can use some trigonometry to find that angle. I believe many of you did a similar problem on the Desmos in class last time we met. I will tell you that the correct measure is 20.92 degrees, and I leave it to you to figure out how to find that. All right, let's suppose I give you 2 points, and I ask you to find the vector that goes from one to the other. The direction it's headed matters because you're going to find a vector that goes from C to D. If I found the vector that went from D to C, I'd get one of the same magnitude, but of course I'd have the opposite direction. Well, the way you do that is you picture it like this. Here's my vector C and my vector D. I want to go from C to D. You're going to subtract the components. So I've got the 17i plus 3j that goes with point D, and then I subtract the 8i plus 25j that goes with point C. And I get 9i minus 22j. If you want to find the position vector that's 3/4 of the way from C to D, it's very similar, but now I'm going from C to D, I want 3/4 of it, so I'm going to multiply the 9i minus 22j that I just computed by figuring out the vector that's going from C to D. I only want 3/4 of that. I'm adding it to the 8i plus 25j because that's my start point. So I go my start point, and then I go a distance in a direction from that point, and I end up at 14.75i minus 22j. And note that when I was trying to find the vector from C to D, you subtract in the order endpoint minus start point. So I did point D minus point C. All right, so that's it for the presentation. Now I'm going to ask you to look at page 309 in your book and do these problems. When you're done, please upload them to Schoology. And that's all. Have a great day.